Good morning, all of you. Today we will see another subtopic in the vapor pressure. A vapor pressure of a solution containing non-volatile solute and volatile solvent. So first of all, I am taking a solution with the non-volatile solute means what? A boiling point is high, means it can't easily evaporate. Another one is volatile solvent. Volatile solvent means what? Boiling point will be low, means just by supplying very little bit temperature, it's undergoing evaporation. Now, I am taking, see for example, vapor pressure or nothing but for example, partial pressure of solvent. From yesterday concept you have to get it. Partial pressure of solvent is directly proportional to which one? Mole fraction of the which particle? That corresponding particle. How much concentration is there? That much of partial pressure is produced by that one. You see carefully, partial pressure of solvent, I want to make it as a equal. Then we have to multiply it with one constant, it is nothing but P0 into mole fraction of the solvent particle. Here we have to observe one thing. Instead of partial pressure of the solvent, I am writing vapor pressure of the solution is nothing but P is equals to P0 into mole fraction of the solvent. So why we written instead of partial pressure of the solvent is equals to vapor pressure of the solution? Once come to the solution point. In the solution, a solute is which one? Non-volatile. Non-volatile means it almost cannot undergo evaporation, means it will not create any pressure. Whatever pressure produced by solvent, because it is a volatile in nature, that pressure is equals to vapor pressure of the solution. Thus far, instead of partial pressure, we are writing vapor pressure of solution P is equals to P0 into mole fraction of the solvent. Write down here, P is equals to P0 into mole fraction of solvent. Here I want to write down one thing. What is that one? Mole fraction of solute plus mole fraction of solvent in every solution is equals to 1. Okay, then what I am doing, mole fraction of solvent is equals to 1 minus mole fraction of the solute. So I am substituting here, see carefully. P is equals to P0 into mole fraction of solvent is what you are writing, 1 minus mole fraction of the solute particles. Okay, just to do simplification. P is equals to P0 minus P0 into mole fraction of the solute particles. Still simplify. This term comes to left, this term goes to right side. Then P0 into mole fraction of the solute is equals to P0 minus P. That implies, write down one more thing, P0 minus P by P0 is equals to mole fraction of the solute. You know very well mole fraction is what? Number of moles of solute by what we are getting? Number of moles of solute plus number of moles of the solvent. Yes, here one important Konnurs question is coming. This is we are calling as a Raoult's law. Yes, what is the Raoult's law? Are you getting that? Yes. This P0, what is the meaning of P0? I will write here. The P0 is equals to which one? Vapor pressure of a pure solvent, not pure solvent, because solute is useless. Why? Because it can't undergo evaporation. What is the meaning of P? Vapor pressure of which one? Solution. Yes, sir? Yes, automatically whatever term is here, P0 minus P by P0 will be there. That is calling as one word is there, relate to lowering vapor pressure. Relate to lowering vapor pressure. Just in shortcut, we are calling it as RLVP. So P0 minus P by P0 is calling as RLVP, relate to lowering vapor pressure. So now I will tell that the Raoult's law statement. You see carefully. What is that Raoult's law statement? Okay. Raoult's law means is a solution in which relate to lowering vapor pressure of a solution which is having non-volatile solute, non-volatile solute and volatile solvent. Volatile solvent always equals to which one? Equals to mole fraction of which particle? Solute particle. This is the statement of Raoult's law. That's only nothing but P naught minus P by P naught is calling as a RLBP. In a solution, RLBP which is containing non-volatile solute and volatile solvent is always equals to mole fraction of the solute particle. That mole fraction of solute in problems we are using this formula is not a matter to us. So Raoult's law means a relative lowering vapor pressure of a solution which is containing non-volatile solute and volatile solvent is always equals to its mole fraction of the solute particle. So many students are doing mistake here. They are writing solvent. God, should not be like that. All of you clear? What are the Raoult's law? Relative lowering vapor pressure of a solution which is having non-volatile solute and volatile solvent always equals to the mole fraction of the solute. That's only we are writing like P naught minus P by P naught. This only we are calling as RLBP is equals to always mole fraction of the solute particles. All of you clear? Yes. Okay. Now we are discussing the very important concept, especially for the competitive examination thing. It's a very careful you have to understand a complete theory concept. See, first of all, I am explaining about the ideal solution. Ideal solutions. So what is the meaning of ideal solutions? Another type will come non-ideal solutions. Together is very important for competitive point of view. What is the meaning of ideal solution? Is a solution which obeys or which follows Raoult's law at all concentrations. It's a very simple thing. We have ideal gas equation. The gas which obeys all gases laws is calling as a ideal gas. Like that, ideal solution means is a solution which obeys or which follows Raoult's law at any concentration. But is a very rare. Why? Because there is no perfect man. Like that, there is no ideal gas as well as ideal solution. Almost some solutions will be there. They are very close to ideal nature, but not perfect ideal solution. So anyway, let it be which solution is calling as ideal solution which obeys the Raoult's law at all concentrations at any concentration. What are the conditions here? See carefully. First point, I am taking solution. The solution is made up of two components. One is solute, another one is solvent. A solute is denoted by A and solvent is denoted by B. Observe very carefully. Every point is very important. Now, in solute, force of attraction between solute AA is equal with the force of attraction between solvent particle BB. Means solvent is denoted by B. So B in between solvent particle, whatever force of attraction will be there, that should be equal with the force of attraction between the solute particle. That should be equal with the force of attraction between solute and solvent particle. That's what we are calling as a solution. What is the point here? In case of ideal solution, whatever force of attraction will be there in the solution between solute and solvent should be equal with the force of attraction between solute and force of attraction between solvent. Such a solution is calling as a ideal solution. Observe very carefully. For example, if you take solute is mixed with the solvent. For example, you are getting an ideal solution. Observe very carefully. For example, 5 ml of the solute I am taking and mixing with the 5 ml of the solvent. Should we get 10 ml of the solution under ideal nature? Okay, but now what I am telling, why we are getting equal? Here, whatever force of attraction will be there, here in all cases we are getting same force of attraction, that's fine. After mixing, we are getting exactly same. Then I want to find out the changing volume of solution. What is the formula? 5 final volume minus initial volume. After mixing, what is the volume? 10. And before mixing, what is the total volume? 5 ml and 5 ml is nothing but 10. We are getting which one? 0. Under ideal solution, change in volume for the solution is equals to 0. These points are important. Okay, means how much volume of solute and solvent you are mixing. Sum of the volume solute you are getting as a solution volume. That's why volume change for ideal solution is equals to 0. And one more point I want to tell you, have to observe very carefully. For example, if you are taking partial pressure of A, solute PA, partial pressure of B is denoted by PB. Total pressure I want, otherwise nothing but vapor pressure of solution should come equals to means these two values. Why? Because this is also, for example, volatile nature, some vapor pressure is there. It is also having some vapor pressure. Together is exactly equals to vapor pressure of the solution. Means under ideal solution, vapor pressure of solution is exactly equal with the sum of the partial pressures of the two components. Here one more thing I want to tell. If you take solute particle, you are dissolving the solute particles in solvent particle, then only we are getting a solution. While dissolving like this, what happening? No bond formation. No bond formation, and as well as no bond breaking. No extra bond formation, no whatever bonds to be present should not be breakdown. No bond formation and no bond breaking. Means, is there any energy changes? Either releasing or absorbing? No. That's why what happening? Enthalpy change for ideal solution should be equals to 0. Whatever energy is remains after mixing also, this part energy is not releasing as well as energy is not absorbing. And you have to see one more thing. It is nothing but, if you take a partial pressure force of attraction like this, now I will give you some examples. It is nothing but, if you take benzene is mixed with toluene, is almost like a ideal nature. Why? It is also non-polar liquid. It is also non-polar liquid. That's why in toluene, whatever force of attraction will be there, that should be equal with force of attraction in the benzene. After mixing also, between benzene and toluene also we have same force of attraction. And if you can see some other example, ethyl chloride C2H5Cl. If you can take bromoethane C2H5Br. If you can take like that benzene, toluene, chlorobenzene. And if you can take hexane. Hexane is mixed with heptane. These all are like which one? Ideal solutions. Why? Because hexane formula C6H14 and it is nothing but C7 and H16 will be coming. Alkane means is nothing but non-polar. That's why in the pure solute and solvent, whatever force of attraction will be there, after mixing also we are getting same force of attraction is calling as a ideal solution. All of you clear? Yes. For this, I will show some information or graphical explanation. I will show you that. See, for example, if you take mole fraction on x-axis, mole fraction should be taken on x-axis, and vapor pressure should be taken on y-axis. Okay, you take first of all mole fraction of the A component is equals to 1. Then automatically chi mole fraction of solvent should become 0. Why? Because sum should be get 1. Means initially we have only one component, A component. Related to its vapor pressure is denoted by PA0. What is the meaning of PA0? Vapor pressure of the pure liquid A denoted by, for example, PA0 will be coming like this. Now what I am doing, I am decreasing the chi A and I am adding slowly chi B. While coming right side, what is happening? After certain addition, chi A is becoming 0. Automatically what is happening? Chi B is becoming 1. Slowly A quantity decreasing and B quantity will be going on increasing. Okay, at this end what is happening? Only B component is there. Corresponding vapor pressure is purely it is nothing but PB0. Are you getting? Means if you see this graph, so while going right side, what happening? A quantity will be decreasing. Yes, sir. A quantity decreasing means corresponding vapor pressure will be also going on decreasing. Yes, directly proportional to mole fraction. It's coming like this. And while going like this regarding B, what happening? Initially 0. While going right side, its quantity will be gradually increasing. That's why corresponding vapor pressure is also going on increasing. Like this will be coming. Okay, now I want total pressure. If you can join these two points, we are getting total pressure. P total under ideal nature is nothing but partial pressure of A plus partial pressure of P component. This is ideal nature solution. Yes, clear? All of you getting on? So what is the condition for ideal nature? So force of attraction between solute particle, solvent particle, solute solvent particle should be equal. So under ideal solution there is no change in the volume of the solution. So and partial pressure of the solution is equals to vapor pressure of the solution is equals to sum of the partial pressures of all components. While dissolving, no bond breaking, no bond formation. That's why no energy changes. Enthalpy change of solution should be 0. And this is the information. All of you clear? Yes. Okay, now we are discussing about, just now we completed ideal solution, now we are discussing non-ideal solution. Okay, whatever solutions we have, all are under control, non-ideal solutions only. Actually, what is the meaning of non-ideal solution? A solution which can't obey the Raoult's law. Which obeys Raoult's law? Ideal. Which can't obey the Raoult's law is calling as a non-ideal solution. Again, non-ideal solutions will be classified into two types. Positive deviation from the Raoult's law, or nothing but positive deviation from the ideal nature. Positive deviation from the ideal nature and negative deviation from the ideal nature. Ideal nature or ideal information. Yes, now we have to, is a very important thing. So first of all, we have to discuss about the positive deviation from the ideal nature. Okay, you see point one by one, you are taking one of the solution made up of solute particle as well as solvent particle. So solute is denoted by A, solvent is denoted by B. So in solute, force of attraction denoted by solute is A. And in force of attraction between the solvent is denoted by BB. Force of attraction between the solvent is BB. Okay, now in the solution what is coming? Force of attraction is coming between solute and solvent. Very important point you have to observe. In case of positive deviation, compare with the solute and solvent attraction, in the solution force of attraction will be less. Means after mixing solute with solvent we are getting solution. In that solution between solute and solvent, force of attraction will be lesser than pure solute and solvent. So due to this one, what happened? You have to see. For example, you are taking 5 ml of solute. You are taking is mixed with 5 ml of solvent. Definitely, we are getting which one? Solution. We are getting. If it is a positive deviation, what happened in the solution? Force of attraction increasing. Force of attraction increasing means volume occupied by the solution will be going on increasing. It comes around 10.2 ml of the solution we are getting. Yes or no? Yes, in the solution force of attraction will be less. Definitely what happens, volume occupied by that will be more than this sum value. Automatically, I want to find out the change in volume for the solution is nothing but final value minus initial value. Final value 10.2 minus initially, how much is there? 10. We are getting how much? 0.2 ml. So 0.2 ml means is it greater than 0 or no? Yes. That's why for positive deviation, we are getting change in volume for the solution should be greater than 0. Okay, next point I am telling that, for example, partial pressure of A component is BA, partial pressure of B component is BB. Now, partial pressure of solution, is it coming equal or less than or greater than? You observe very carefully. In solution, force of attraction will be less than solute and solvent. Force of attraction will be less means evaporation character will be more. Evaporation character will be more means pressure of solution will be more than this sum value. Are you getting out? Yes, this is a very important point. Later, what happening whenever you are mixing solute with which one? Solvent. What happened? Force of attraction decreasing. Force of attraction decreasing means what happening? Yes, very good. Bonds are breaking. Bonds are breaking means very simple phenomena. Energy consuming, energy releasing. nothing but energy is absorbing or requires. Energy absorbing reactions is calling as endothermic reactions. Yes or no? Endothermic reaction means enthalpy change for the solution. Is it coming? Greater than 0. Positive values we are getting exothermic, negative values is coming. All of you getting or no? Yes. Later we have to see some example for this one. It is nothing but what has to be done? After mixing, force of attraction has to be decreased. Best example for this, it is nothing but ethanol plus hexane. It's very careful you have to observe. Ethanol means alcohol. In that, alcohol molecules are connected with the hydrogen bond. But hexane want to dissolve. Want to dissolve means it has to be break down the bonds. After breakdown of bonds, force of attraction between them will be less. Okay, anyway, processes takes place by breaking of bonds. Breaking of bond means energy taking. Energy taking means is very better. That's why it's the best example. Like that, we can give some other example is nothing but ethanol plus water. And if we can give some other example, nothing but ethanol plus and acetone. Acetone we can take. Otherwise, we can take acetone as well as acetone and benzene. These all are under terms same concept. Why? Because while dissolving, whatever force of attraction will be there in the solvent should be break down. All of you getting? Did you observe one small logic here? So except the force of attraction in the solution, remaining all terms is coming greater than 0. Positive. Simply remembering all terms is greater than 0, but except the force of attraction. Force of attraction will be coming lesser than solute and solvent attraction. For this, I am drawing the graphical explanation how to see carefully. Same, it is nothing but which one now? Mole fraction. Mole fraction you are taking on x-axis. Vapor pressure we are taking on y-axis. Initially we have chi A is equals to 1. Automatically chi B is equals to 0. Purely A component is there. That's why its vapor pressure is nothing but PA naught. While coming right side means you are decreasing the A and increasing the B. Then chi A is equals to 0. And chi B is equals to 1. Only which component is there? B component. Corresponding vapor pressure is denoted by which one? PB naught. A pure vapor pressure. So generally, if it is ideal solution, means what has to be there? This line has to become like this. Straight line has to become. If it is the ideal nature, is it ideal? No. It's a non-ideal solution, but the positive deviation. Actually, we have to get if it is ideal means like this line has to become. But it is not coming like this. Then your expectation, we are getting all the values to be greater than 0. Greater than means then our expectation, we are getting some extra values we are getting. That's why we are denoting like upper line. That is indicates positive deviation. Yes, dotted line is ideal nature. It's not ideal. It is a positive deviation. Means then our expectation, we are getting all the values should be more. That's why here we are getting like this upper lines we are getting. All of you understood all of these things? Yes. Now, under non-ideal solution, second category, negative deviation from the ideal behavior. What the negative deviation we will discuss? The solution is made up of two components, solute and solvent. In the solute, what attraction will be there? Solute attraction will be there. In the solvent, we have force of attraction between solvent denoted by V and V. Compare with solute solvent attraction. In the solution, force of attraction will be more between solute and solvent. That is denoted by force of attraction between solute and solvent should be more than solute solvent attraction. Then the solution is calling as a negative deviation from the ideal nature. So first point. Let us see, I am telling, for example, 5 ml of solute is mixed with 5 ml of solvent. Like this bits only asking in the board examination under one more question. So 5 ml mixing, then I am getting for example 9.8 ml of solution. Is it possible? Possible. Why? you see carefully, after mixing we are getting solution volume will be less. Why? In the solution, force of attraction will be more. Automatically the molecules are closely packed. Definitely the resultant volume should be lesser than some of those components. So then we are getting change in volume for the solution is equals to final minus initial value. Final is how much? 9.8. Before mixing 10 ml. So 9.8 minus 10 is coming how much? Minus 0.2 ml. Anyway, is it less than 0 or greater than 0? Less than 0. That's why for negative solution, change in volume for the solution is less than 0. Next point I want to discuss, pressure of A component is PA and pressure of B component is PB, and but pressure of solution is like this. Is it coming equal? No. Why? Then the sum of the value in the solution, force of attraction will be more. Force of attraction will be more. Evaporating nature will be less. Automatically creating pressure will be less. That's why resultant solution pressure is less than sum of its components pressure. And later I want to tell one more thing. Whenever you dissolve solute particle in a solvent particle, what happens? Force of attraction will be increasing. Force of attraction is increasing means what? Bonds are forming. Means while dissolving a new attraction will start or new bonds are undergoing formation. Bond formation is always energy releasing process. Energy releasing process means what? Exothermic reactions. Exothermic reaction means what is coming? Enthalpy change